Lesson 5.3 focuses on annuities. We're going to begin with a few basic terms for annuities. An annuity is a sequence of equal periodic payments. When the deposits are made at the same time and the interest is credited, the annuity is ordinary, and these are the annuities we're going to focus on in this course. Well, the final amount of the annuity is the sum of all the deposits plus all accumulated interest. In this course, we're going to think of an annuity as a compound interest account that you can add money to from time to time. But for simplicity, you can only add the money to it when it's being compounded. So if it's compounded monthly, you can make monthly deposits. If the account is compounded yearly, you can make yearly deposits. And these deposits are going to be the same amount every time. With this course, we're not getting into the complicated accounts where you deposit different amounts of money each time. We're going to always deposit the exact same amount of money. So let's look at the formula. We have A equals P times, and then we have a large fraction. In the numerator, we have 1 plus R over N raised to the NT power, and all of that is being subtracted by 1. And then in the denominator, we have R divided by N. With the variables, A is the final amount of the annuity, P is the deposits or the payments being made. This time, instead of P being a principal, we're not depositing a lump sum up front and just leaving it in the bank as we did in the previous lessons. This time, we're making monthly deposits, and that's what our P represents. R is the interest rate, and we always write this as a decimal. T is the time, and it's always in years. And N is the number of times per year the account is compounded. The purpose of this formula is to find the final amount of an annuity. And with this count, you're making deposits or you're making payments in order to have a certain amount at a future date. In the next lesson, we're going to look at the present value of an annuity. But this lesson is focusing on a future amount. This is something that we're saving up for. Now be sure you study the formulas as I give them to you, because these are the way the formulas are going to appear on the quizzes and the test. Some books, even though the formula is the same, they may use different variables or different letters. I told you in a previous lesson that I like to multiply the NT before I plug it into the formula. Some books take that NT and they write it as a single variable, and it's usually an I. So they would have 1 plus R over N to the I power. And some books even take the R over N and make it be a single variable. So be sure you study the formulas that I'm giving you. So let's look at the first example. You want to set up a college fund for your 2-year-old child. You can give $100 per month to this fund that's compounded monthly at 6% interest. How much will your child have at age 18? So the first thing you need to decide, it's a compounded account. So we're not using the simple interest account. I know it's compounded because I see the word compounded in the problem. The second thing you need to decide is, what am I doing with my deposits? Am I making a one-time deposit and leaving it alone and letting it sit in the bank? Or am I making repeated deposits? This time I'm depositing $100 per month, so it's repeated deposits. And that's the lesson 5.3 formula. If I was simply depositing $100 and leaving it into the bank for years for it to grow, that would be a simple compound interest account, and that was the lesson 5.2 formulas. So since I'm making repeated deposits, I'm going to use the formula A equals P times 1 plus R over N to the NT power, all minus 1, divided by R over N. And as I did before, I want to list what my variables are. A is the final amount of the account, and that's what I'm looking for. P is the deposits that I make, the amount of each deposit. Well, I'm making $100 deposits each month, so my P is 100. R is my interest rate, which is 6%, If I divide that by 100, I get 0.06. N is the number of times compounded. It's compounded monthly, so that's 12 times per year. And T is my time in years. Well, my child is already 2, and I'm going to use this account until the child reaches 18. So 18 minus 2 gives me 16 years that I'm going to add money to this account. Now, to make it easier, I always go ahead and multiply N times T, and 12 times 16 gives me 192. So these are the values that I'm going to plug into my formula. So A equals 100 times 1 plus 0.06 divided by 12 raised to the 192 power minus 1, and all of that's divided by 0.06 divided by 12. So when you enter this in the calculator, you need to be very careful in a couple of places. I'm going to begin inside the large parenthesis. In the numerator of the large parenthesis, I'm going to begin with the 1 plus 0.06 divided by 12, just like we did with the compound interest problems from the previous lesson. Once I type that into my calculator, I'm going to raise that to the 192 power, and then I'm going to subtract 1. After I do that, I'm going to divide by the 0.06 divided by 12. You've got to be really careful when you're dividing by a fraction and not using the fraction button. Since this is a decimal in the numerator, I can't use my fraction button. So when you divide by a fraction, you have to put that fraction in parentheses, and we will do that on the calculator. Then after we divide by that fraction, we're going to multiply that final answer by 100. So let's look at this on the calculator. So as we mentioned, we're going to begin with the 1 plus 0.06 divided by 12. So I have 1 plus 0.06 divided by 12. And then hit equals. We're going to raise this to the 192 power. And then hit equals. Then leave that in your calculator, and we're going to subtract 1 and hit equals. Now this is the part you've got to be careful with. We're dividing by that fraction. So I have to say divided by, and then I'm going to open up a parenthesis. And if you notice up here you have your parenthesis symbol, so that means you're entering what's inside that parenthesis. Well, inside the parenthesis I have 0.06 divided by 12. And then close your parenthesis. Now this is the value that I'm dividing by. It's 0.005. And then hit equals to actually perform the division. Now that takes care of everything in my large parenthesis. Now I need to take this and multiply it by 100. And that gives me 32,109.13367. And that decimal continues on off my calculator screen, but this is the answer I'm going to use for my final rounding. So let's look at these steps on paper. So when we typed 1 plus 0.06 divided by 12, we got 1.005. Then next we raised that to the 192 power. When we raised that to the 192 power, we got 2.605. And then we subtracted 1, and we got 1.605. And that number continued on. Now on your paper, you can write as few of these steps or as many of these steps as you want. In the notes and in the homework, I'm trying to list a couple of steps just so you can check the decimals as you do this on your calculator. But on the computer, you're only going to be giving me the final answer, so it doesn't matter how many steps you write in each problem. Now I need to take that 1.605, leave it in your calculator, and I need to divide by 0.06 divided by 12. This is where you have to use the parentheses. So you divide by, open up a parenthesis, and then type 0.06 divided by 12 and close the parenthesis, and then hit equals. And when you do that, you get 321.091, and that decimal continues on. Now with that decimal in your calculator, you multiply by 100, and that gave us the 32,109.1336. Since this is money, we're going to round it to 2 decimal places. So that gives us 32,109.13. So that means that after 16 years, when my child turns 18, I would have $32,109.13 in the college fund. Let's look at the next example. You invest $200 per month into a fund that's compounded monthly at 5% interest. How much will you have 20 years from now? The first thing I need to decide is this account a simple interest account or a compound interest account? Since I see the phrase compounded monthly, I know it's a compound interest account. The next thing I decide is, am I making a single deposit or am I making multiple deposits? This time I'm investing $200 every month, so I'm making multiple deposits. So this is the 5.3 formulas. So I have A equals P times 1 plus R over N to the NT minus 1, all divided by R over N. So now let's find the value for each variable. A is the final amount, and that's what I'm looking for. P represents my deposits, and I'm depositing $200, so my P is 200. R is the interest rate, 5%. If I divide this by 100, I get 0.05. N is the number of times compounded per year. I'm compounding monthly, so that's 12 times per year. And T is my time in years. This is 20 years, so T is 20. And as before, I like to go ahead and multiply my N times my T. 12 times 20 is 240. So now plug these into your formula. P is 200 times 1 plus R is 0.05 divided by N is 12. That's raised to the NT, which I found was 240, minus 1. And all of that is divided by R over N, so divided by 0.05 divided by 12. So now to enter this into my calculator, you begin with the numerator, and I'm going to type in 1 plus 0.05 divided by 12. I'm going to take that answer and raise it to the 240th power. Then I'm going to subtract 1. Then I'm going to divide by the 0.05 divided by 12, and I have to put that in a parenthesis. And then I'm going to take that final answer and multiply it by 200. So let's do this on the calculator. So begin with 1 plus 0.05 divided by 12. So I have 1 plus 0.05 divided by 12 and press equals. This gives me 1.0041, and that decimal continues on. Now I want to raise that to the 240th power. So press your exponent key, and then enter 240 and press equals. And this gives me 2.7126. Leave that in your calculator and subtract 1 and press equals. And that gives me the 1.712. And that decimal continues on. Now I need to divide that by 0.05 divided by 12. So divided by, and remember this fraction has to go in a parenthesis, 0.05 divided by 12, and close your parenthesis. And then press equals to actually perform the division. And this gives me 411.033, and that decimal continues on. Leave that in your calculator and multiply by 200. And that gives me 82,206.733, and that decimal continues on. So let's look at this on paper. I began with the 1 plus 0.05 divided by 12, and that gave me 1.0041, and that decimal continued on. When I raised that to the 240th power, I got 2.71. Then when I subtracted 1, I got the 1.71, and that decimal continued on. When I divided by the 0.05 divided by 12, that gave me 411.033, and that decimal continued on. Then I multiplied by 200, and I got the 82,206.733. Since this is my final answer, this is the only time I round. So it's money, round to 2 decimal places, and we get $82,206.73. So that means in 20 years, I'm going to have the $82,206.73. In the next example, a 35-year-old man decides to invest in an IRA. He will put aside $2,000 per year into an account which has a return of 5.5% per year. If he does this until he's 65, how much retirement money will he have? So it's a compound interest account because he gets a return of the 5.5% each year. Then you decide, am I making one single deposit or repeated deposits? He's depositing $2,000 each year, so it's repeated deposits. So I'm going to use the formula from lesson 5.3. A equals P times 1 plus R over N raised to the NT power minus 1 divided by R over N. A is the final amount, and that's what I'm looking for. P is the amount of my deposit, so I'm depositing $2,000 each year. R is the interest rate, which is 5.5%. If I divide that by 100, I get 0.055. N is the number of times compounded per year. Well, it says he has a return of 5.5% per year, so that means they're compounding this yearly, so that's once. My time is the number of years. The man is 35 years old, and he's going to do this until he's 65. So he's going to do this for 30 years. If you say 65 minus 35, you get the 30 years. And this time, if I multiply the N times T, 1 times 30 is just 30. So plug this into your formula, and you get A equals 2,000 times 1 plus 0.055 divided by 1 raised to the 30th power minus 1, and all of that's divided by 0.055 divided by 1. Now, to make the calculator part a little easier, since I'm dividing by ones, you could drop those ones. And 1 plus 0.055, this entire parenthesis would just give me 1.055, and the denominator would just be 0.055. I'm going to go ahead and do the divided by 1 on the calculator just so you can see it for practice. But if you wanted to simplify these before you get to the calculator, you could. So we're going to begin with 1 plus 0.055 divided by 1. So 1 plus 0.055 divided by 1 equals, and that's the 1.055 we said we would get. Now I'm going to raise this to the 30th power. So press your exponent key and type in 30 and hit equals. And that gives me 4.9839, and that decimal continues on. Then I'm going to subtract 1. And that gives me 3.983, and that decimal continues on. Now I'm going to divide by the 0.055 divided by 1. And as I said before, if you just want to divide by the 0.055, you wouldn't need the parentheses. But if you leave the 1 in there, let's go ahead and use the parentheses. So divided by parenthesis 0.055 divided by 1, and close your parenthesis and press equals. and that gives me 72.435, and that decimal continues on. Now I'm going to multiply this by 2,000. So times 2,000, and that gives me 144,870.9559. So when we entered the 1 plus 0.055 divided by 1, we got 1.055. And to save room on the computer screen, I've dropped the 1 in the denominator as well. When we raised that to the 30th power, we ended up with 4.98, and that decimal continued on. Then when we subtract 1, we got 3.98, and that decimal continued on. Then we divided by the 0.055 divided by 1, and that gave us 72.43, and that decimal continued on. And then we multiplied by 2,000, and we got the 144,870.9559. Since this is our final answer, this is where I'm going to round. And it's money, so I'm going to round to 2 decimal places. So I end up with 144,870.96. So if the man deposits $2,000 per year for 30 years, he would end up with $144,870.96. Well, in the next example, let's suppose the man from the previous example had started the above account 10 years earlier. This time he's making those deposits for an additional 10 years. So I'm going to use the same formula. My A is still what I'm looking for. He's still depositing $2,000. The interest rate is still 5.5%. If I divide that by 100, I get the 0.055. My N is still 1. It's still compounded once per year. But this time my time is 40 years. So my N times T would be 1 times 40, which is 40. So plug this into your formula. And we get 2,000 times 1 plus 0.055 divided by 1 raised to the 40th power minus 1, and that's divided by 0.055 divided by 1. I'm going to skip the part where I show you how to do this on the calculator, since the only thing that's changed is the time. So you're going to enter in the 1 plus 0.055 divided by 1. And when you do that, you should still get the 1.055. Now raise that to the 40th power. So on your calculator, you're going to leave this 1.055 on your calculator screen. Press the exponent key and type in a 40 and hit equals. When you do that, you should get 8.5133, and that decimal continues on. Now with that 8.5133 in your calculator, subtract 1, and that gives you 7.5133. Now divide by the 0.055, and that will give you 136.605. Leave that in your calculator and multiply by 2,000, and you get 273,211.2281. Since this is your final answer, we're going to round to 2 decimal places because it's money. So we get 273,211.23. So this time, the man will have $273,211.23. If you notice from the example above, you increase your retirement money by almost $100,000 by beginning to invest 10 years sooner. With compounded accounts, the key to making the most money is time. The sooner you begin investing, the more money you will have. Well, what if we wanted to find the payments needed to obtain a certain amount of money after so many years? So suppose you're saving up for the down payment on a house, or you're saving up for a car. In the previous lesson, we looked at the situation where we deposited a lump sum amount and let it set in the bank for those years. Well, suppose you don't have that large amount of money to deposit right now, and you want to deposit money each month in order to build that account, or you want to deposit money each quarter in order to build that account. So since you're making multiple deposits, we're using the same formula, but we're going to use the trick that we did in the previous lesson. This time, if I need to find my payment amount or my deposit amount, I'm solving for P. So I'm going to switch the A and the P, and I can do that as long as I raise that entire parenthesis to the -1 power. And this is just going to be pressing one extra button on the calculator, and I'll show you how to do that. Since all I did was rearrange this formula, all my variables represent the same thing. A is still the final amount, P is still my deposits or my payments, R is still the interest rate, T is still the time, and N is still the number of times compounded per year. Well, the purpose of this formula is to find the payment or the deposit amount needed for a certain final amount. And with this account, you're finding out how much you need to deposit into an annuity to have a certain amount at a future date. That's going to be key when we get into the next lesson, is that this lesson 5.3 deals with future values. One other note with this formula, in the previous lesson, we had A equals P times 1 plus R over N to the NT. That was all we had. So this was the only thing we were dividing each side by when we were solving for P. So that's why the NT became negative. This time, if we're solving for P, we're going to divide by the entire parenthesis, the outside large parenthesis. That's why its exponent is what becomes negative, not the NT. The -1 goes to the entire fraction, that large fraction, that large parenthesis. So make sure that the NT in this formula is not negative. Well, let's look at the example. A 25-year-old man wants to have a retirement fund of $400,000 by the time he reaches age 60. He invests in an account which yields 6.5% interest compounded monthly. What should his monthly payments be? So the first thing I decide is this is a compounded account. And next I decide, am I making one lump sum deposit or am I making repeated deposits? He's making monthly deposits or monthly payments. So this is going to be our lesson 5.3 formula. Now I need to decide, am I looking for the final amount or am I looking for the payments? Since I'm looking for the payments or those monthly deposits, I'm going to use the formula P equals A. So P equals A times 1 plus R over N raised to the NT minus 1 divided by R over N, and all of that is raised to the -1 power. For my variables, A is my final amount. He wants $400,000 in his retirement account, so the final amount that he wants is $400,000. P is the monthly deposits or the monthly payment, and that's what I'm looking for. R is my interest rate, which is 6.5%. If I divide that by 100, I get 0.065. N is the number of times compounded per year. It's compounded monthly, so my N is 12. T is the number of years. Well, he's wanting to retire when he's 60, and he's 25 now. So if I say 60 minus 25, I get 35 years. So he's going to add to this account for 35 years. Then to make it simple, go ahead and multiply your N times T and you get 420. So plug these into your formula. So I get P equals 400,000 times 1 plus 0.065 divided by 12, all raised to the 420th power. That's being subtracted by 1. And then I divide by 0.065 divided by 12. After I do that division, I raise that parenthesis to the -1 power. And then I take that answer and multiply by 400,000. So let's look at this on the calculator. Before we look at the problem from that example, let's just look at raising something to the -1 power. And I'm going to show you 2 ways to do that. So let's just consider the number 2 raised to the -1 power. If I use my exponent key, I'm going to start with my base of 2. I'm going to raise that to the 1 power, but then hit my plus or minus to make it negative. And that gives me 0.5. I want to look at another way to do this. Raising something to the -1 power is just taking its reciprocal. This is your reciprocal button, your 1 over x. So if I wanted 2 to the -1 power, I could type in 2 and hit that 1 over x, and it flips the 2. It takes the reciprocal of the 2, and I still get the 0.5. So you can use either method you want to. So let's look at another example. If I have 4 to the -1 power, 4, use your exponent key and type in 1 and then negative. That would be 1/4, which is 0.25, and that is what I get on my calculator. The other way to do it is to enter the 4, and to raise it to the -1 power is to take its reciprocal. So press 1 over x, and you still get the 0.25. So using the 1 over x key instead of raising it to the -1 power just saves you a few punches on the calculator. And you can do these either way you want. You'll get the correct answer. So now let's look at the problem from the notes. I'm going to begin with the parenthesis in the numerator. So I have 1 plus 0.065 divided by 12. So 1 plus 0.065 divided by 12 and press equals. And that gives me 1.005, and that decimal continues on. Now I raise that to the 420th power. So use your exponent key and type in 420. And that gives me 9.668. Leave that in your calculator and subtract 1. That gives me 8.668. Now I need to divide that by the 0.065 divided by 12. And I have to use my parentheses for this. So divided by parenthesis 0.065 divided by 12 and close your parenthesis. And then be sure to hit equals to actually perform that division. When I do this, I get 1,600.3161, and that decimal continues on. This is the value that I raised to the -1 power. So you can either do your exponent key and type in a 1 and then the plus or minus, or you can simply press the reciprocal button. If I press the reciprocal button, I get 0.0006, and that decimal continues on. Now I multiply this by 400,000. When I do this, I get 249.9506, and that decimal continues on. So as I go through the steps, you practice this in your calculator. I have 1 plus 0.065 divided by 12, and that gave me 1.0054. When I raised that to the 420th power, that gave me a 9.66. Then subtract 1, and you get 8.66. And all of these decimals continue on. Then divide that by 0.065 divided by 12. So you've got to put the 0.065 divided by 12 in parentheses. When you do this, you get the 1,600.31. Leave that in your calculator and raise that to the negative 1 power. When you do that, you got 0.00062. Leave that in your calculator and multiply by 400,000, and you get 249.9506. Since this is our final answer, round to 2 decimal places, so we get 249.95. So that means in order to have $400,000 in the retirement account, the monthly payment should be $249.95. The next example is just like the previous example. The only thing this time, the man is 10 years older. Suppose he didn't start saving until he was 35. Instead of starting at 25, he waited until he was 35. So I'm still using the same formula. My final amount is still the $400,000. I'm still looking for my monthly deposits. The rate is still 6.5%. If I divide by 100, I get 0.065. It's compounded monthly, so my N is 12. But this time, my time is 60 minus 35, so I'm only saving for 25 years instead of the 35 years from the previous problem. So just keep in mind the time is not the current age, it's not your retirement age, it's the number of years that you're investing this money. So now when I multiply N times T, I get 300. So plug this into your formula. So P equals 400,000 times 1 plus 0.065 divided by 12. This time it's raised to the 300th power. Then minus 1 divided by 0.065 divided by 12. And all of that's raised to the negative 1 power. So on the calculator we begin with 1 plus 0.065 divided by 12. So 1 plus 0.065 divided by 12 and hit equals. Now raise this to the 300th power and press equals. And we get 5.056 and that decimal continues on. Now subtract 1 and we get 4.056. Now I need to divide that by 0.65 divided by 12. So divided by, parenthesis, 0.065 divided by 12, close your parenthesis, and then be sure to press equals to do the division. And that gives me 748.836, and that decimal continues on. Now I need to raise this to the negative 1 power, so I'm going to use my reciprocal key. And that gives me 0.00133. Now multiply this by 400,000. And that gives me 534.1619, and that decimal continues on. So let's list some of those steps on paper. When I typed in the 1 plus 0.065 divided by 12, that gave me 1.0054, and that decimal continued on. Next, raise that to the 300th power, and that gave me 5.056. And then when I subtracted 1, I got 4.056, and that decimal continued on. Next, divide by the 0.065 divided by 12. And remember, that's the step you have to use your parentheses. When I did that, I got 748.83. Next, we raised that to the negative 1 power, so I pressed my reciprocal button, and I got 0.001335. Then leave that in your calculator and multiply by the 400,000, and we got 534.1619. This is our final answer, so this is where we round, and it's money, so round to 2 decimal places. So we end up with $534.16. So this time the man's monthly payments would be $534.16. So by waiting 10 years to start investing, he has to invest more than twice the amount of money he would have if he had started 10 years sooner.